In this lesson, we're going to talk about how to simplify complex rational fractions. Sounds scarier than they are, but it's really just a variation of division. So first, you need to make sure you understand what a complex fraction is. It's basically a fraction where the numerator and denominator both are fractions. So for example, 1 over 2 over 3/4 would be considered a complex fraction. And basically, remember that division can also look like a fraction bar, means that this problem is equal to 1/2 divided by 3/4. And that's the secret to simplifying them. If we can go ahead and rewrite this as a division problem, when we simplify it, we'll end up with a single fraction. No complex about it. Okay, so recall that since dividing since a complex fraction really means division, to simplify it, we're just going to make sure that the numerator and denominator just have single fractions in them. Set up a division problem by changing it to multiply by the reciprocal, and then simplify when we factor. Okay, let's go over a couple ones. Okay, so let's go ahead and start with this one. It's relatively easy. So it says 6 over xy, nothing I can do to simplify that, times divided by 3y over 8x cubed. So that's it as a division problem. So now we're going to go ahead and transform this into multiplication. So I have 6 over xy times the reciprocal 8x cubed over 3y. And now we go ahead and simplify. So I know that x goes into x once, making that x squared. 6 has a common factor with 3 of 2. 6 and 3 are both divisible by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1. Since both y's are in the denominator, can't simplify those. And since the 2 and the 8 are both in the numerator, we can't simplify those, so we multiply across. So I have 2 times 8, which is 16. Nothing times x squared, which gives me x squared. Y times y, which is y squared. So now it's simplified because the numerator and denominator have no common factors, and it's a single fraction. Okay, now these are looking a little more complex, huh? So let's go ahead and look at this one. So first I look at each individual fraction to make sure I can't simplify it. If I can't, I rewrite it as a division problem. 8p minus 2 divided by 4p squared over 4p minus 1. Now, my next step, it's up to me. I can go ahead and I can factor where I can and then change it to a multiplication problem, or change it to a multiplication problem and then factor. However works. I'm going to go ahead and do both at the same time. So I know that 18p is not factorable, but 8p minus 2, both of those terms are divisible by 2. So now 18p can't be factored, but 8p is divisible by 2, giving me 2 times 4p minus 1. Changing division to multiplication, 4p minus 1 is now my new numerator, and it cannot be factored, and 4p squared is now my new denominator. Now I simplify. Well, 18 and 4 have a common factor of 2, and because these are both monomials, I can just go ahead and use division. P squared and p have a common factor of p to the first, so I can simplify that. And then 4p minus 1 goes exactly into 4p minus 1, and now I go ahead and multiply what's left over. In the numerator, I'm left with only the factor 9. In the denominator, I'm left with a factor of 2 times p to the first, which would be 4p. Okay, now we're going to go ahead and look at number 8, which has a little bit more factoring to do, and it's a bit more complicated. So the first thing I'm going to do in number 8 is rewrite this so I have two fractions. 2m squared minus 2m minus 40, 3m plus 12, and I'm going to rewrite it as times the reciprocal. 9m squared plus 36m over m cubed minus 5m squared. Now I'm going to go ahead and factor what I can. So I know this is the same as 2 times m squared minus m minus 20, which means its factors to 2m minus 5 times m plus 4. My denominator, both terms are divisible by 3. And in my numerator, my second one, both are divisible by 9m. And in my denominator, both are divisible by m squared. And now I cancel what I can. So I see m minus 5 in both. And I also see m plus 4 in both. It doesn't matter which one, I go ahead and cancel. Okay, 3 divided by 3 is 1, and 9 divided by 3 is 3. M over m squared gives me 1 over m to the first. Now I multiply what's left over. 2 times 3 times m plus 4 gives me 6m plus 24 if I multiply it out. In my denominator, I'm just left with an m, which gives me that. Now, as we get into problems like numbers 9 and 10 here, it gets even a little bit tougher. And that's because we have denominators, we have fractions that have additional operations in them, such as subtraction and addition, which means we have to follow order of operations. So let's go ahead and start with number 9. So if I went ahead and I wrote this out, I would have x over 3 minus 3 over x, which is grouped, times the reciprocal of x over x minus 3. So order of operations says that before I go ahead and I do the multiplication, I have to do what's grouped first. So first I need a common denominator for 3 and x, which would be 3x. So I know I have x squared minus 9 in my numerator over 3x for my denominator. Now I can go ahead and factor x squared minus 9. That's going to give me x plus 3 times x minus 3, because it's difference of squares, over 3x times x over x minus 3. And now I simplify. X plus, oops, sorry, wrong one. X minus 3 over x minus 3, they cancel. X and x cancel. And then it leaves me x plus 3 in my numerator over 3 in my denominator. So in this one, I want to take a different approach. And that's because my denominator, I can't just reciprocate it. So I'm going to go ahead and I'm going to simplify the numerator and the denominator first by going ahead and doing the subtraction and addition. Okay, so first I need a common denominator for a squared and b squared, which would be a squared b squared. So I know I have b squared over a squared b squared minus a squared over a squared b squared, which gives me b squared minus a squared over a squared b squared. Okay, now I'm going to do my denominator. In my denominator, I have 1 over b plus 1 over a, so my common denominator would be ab. So I'm going to make a over b plus b over a. Now I'm going to go ahead and take these. This is my numerator. This is my denominator. I'm going to write it as a single problem at multiplication. So in my numerator, I have b squared minus a squared. I'm sorry, my first term, I have b squared minus a squared over a squared b squared. Then I have times the reciprocal. Sorry, I forgot to write those denominators correctly. The reciprocal of, I forgot to combine too. A plus b over ab. Okay, now I gotta reciprocate it. AB over a plus b. Okay, now I'm ready to go ahead and simplify. B squared minus a squared is b minus a times b plus a. And a squared b squared, we'll take care of that later, bb over a plus b. Now, because of the commutative property, b plus a is exactly the same as a plus b, don't have to worry about factoring out a negative. A goes into a squared once, and b goes into b squared once. So what are we left with? Let me go ahead and move up here. B minus a in my numerator, and ab in my denominator. That one was really complex, huh? Okay, so let's go ahead and do the great last one. And that's number 16. And again, we're going to go ahead and first add and subtract the numerators and denominators terms. And then we're going to go ahead and do the division. Okay, so a over a plus 3 plus 1/5 means I have nothing in common, so the product is what my common denominator is. Okay, so I end up with 5a plus a plus 3 in my numerator over 5 times a plus 3. Combining like terms, I get 6a plus 3 over 5 times a plus 3. And 6a plus 3 factors to 3 times a plus 1, 5a plus 3. Okay, so that's my denominator. Okay, numerator, I have a squared over a plus 3 plus a squared times 5 a plus 3, which means I'm missing a 5 over here on the left term. So I multiply both numerator and denominator by 5, which gives me 5a squared plus a squared over 5 times a plus 3. And when I factor that, or simplify that, I get 6a squared over 5 times a plus 3. Okay, so now we're going to put all this together. So I have in my numerator 6a squared over 5a plus 3. Remember, this needs to be reciprocated. So I need to multiply by 5 times a plus 3 over 3 times a plus 1. Okay, we're ready to go. A plus 3 cancels a plus 3, 5 cancels 5, 6 and 3 are both divisible by 3, and I'm left with a squared over a plus 1. So complex fractions really isn't too big of a deal. It's just taking it and making it into a multiplication problem and kind of adding in some of the other stuff we learned about adding and subtracting fractions.